Hello from ChemHelp ASAP. We're going to talk about bonding in a very simple molecule, the H2 molecule, hydrogen gas. Okay, so when we talk about bonding and energy and this sort of thing, we have to start with an energy picture. And for our energy picture, we're going to again draw our axis. That's our energy axis. For our bond, remember this is our H2 molecule, we start with a hydrogen atomic orbital. That's the 1s orbital. It's the only valence orbital we have in hydrogen. And we have our starting atomic orbitals on the left and right. They're both going to have an electron, and then we mix them together. One of the new orbitals will be higher, one other will be lower in energy. This is one of our new molecular orbitals down here and another on top, and this is our bonding orbital, and up top is our antibonding orbital, and it's vacant. The electrons go to the lowest energy orbital. That's our energy picture. All of our energy pictures will look really close to this thing on the left. Now let's try to draw our orbitals. So what are we going to have to do this? Well, we're going to take an s orbital. Here's an atomic orbital. This is from one of our hydrogens, and it's going to be in very close proximity to another hydrogen orbital. That's an atomic orbital. I'm going to shade both of these to signify that they're both positive. Let's hash them in different directions. Now when these two orbitals come together, you notice there's a place in here where they overlap. That's important because we get an additive effect. Note that we're doing addition between these two orbitals. And so as we draw our new molecular orbital, we're going to show our bonding molecular orbital. Again, we have our two hydrogens close in space, and the overall orbital looks something like that. And the whole thing is shaded. Now on the left we have what we've sketched out is the wave function, the psi, for our atomic orbitals. And what we've done on the right is sketched out the wave function for our molecular orbital. Now we want to wonder, where is the electron in this orbital? We're going to draw a very similar picture. This can be confusing because very often our probability function looks almost identical to our wave function. But if we square our wave function, we get something that looks remarkably similar. And that's because since our molecular orbital is all positive, our wave function is all positive. But if we look at where our electron is in this orbital, it's pretty much in between the two nuclei. Well, that's why this molecular orbital, this new molecular orbital, is so stable. The electrons are between the two nuclei. And when we think about it being stable, we get nice low energy electrons. That is our bonding orbital. Now let's talk about our antibonding orbital. Now I think the idea of S minus S is really confusing because that sounds to me like that should equal 0, S minus S. Remember, these are S orbitals on different atoms. Another way to think of this is S plus the negative of an S. So let's put our two atoms next to each other. Here's one, here's our s orbital, and this is right next to another s orbital that is not shaded because it's negative. So here's our positive side, here's our negative side. Once again, these are atomic orbitals, these are wave functions. And when we mix these, it's going to look different because we now have this region in the middle where they overlap and they actually cancel each other out. So what we get when we add these together, on the left we get some kind of positive value, on the right we get a negative value, it's unshaded, and what we get in the middle is where these things have canceled out. This is called a node. And so here is our molecular orbital. We've sketched out the wave function. Note, it always, when we mix two atomic orbitals, we have one way of mixing them, a second way of mixing them. Let me get my cursor back. The second way of mixing them, and what do we get? We get one, and over here, two molecular orbitals. We saw that in our energy picture. One molecular orbital antibonding and one bonding. So let's now look at the psi squared for this. When we look at psi squared, the psi squared tells us where the electron is. Now the left-hand side is still positive, but the right-hand side, which was negative, now becomes shaded becomes positive. So here is our psi squared. It tells us where the electron is. And now, where is the electron? Well, for the most part, it is outside the internuclear axis, this space right in here. And so those are going to be high energy electrons. This basic picture that we've drawn up for bonding and antibonding and the energies, if you understand these pictures, you understand all the pictures that we're going to show in later videos about bonding. They are all just derivatives of what we've shown. So it's important to understand this simple molecule, hydrogen, which is not an organic molecule, but we can use a hydrogen molecule as a simple model to understand more complex structures, like our organic structures.